Hello, welcome everyone. Today we will discuss business math using simple interest using business mathematics in Canada. This is owned by McGraw-Hill. All right, let's look at the simple interest. There's quite a number of objective. Number one is calculate the interest maturity, present value, rate, and time in simple interest environment. Number two, present detail in the amount of timing and payment as well as in time of diagram. Number three, calculate the equivalent value of any date of single payment stream of the payment. In terms of the payment of the interest, simple interest, that play an important role in your personal business life every day. For example, when I start my schooling, I use borrow money using credit card. So that's the first thing I do, is to establish a credit records. Interest is the fee that lenders charge to borrow for the use of their money. Simple interest is used in terms of short-term loans as well as for any investment. And we will learn how to calculate simple interest on these particular chapters. What is simple interest? The basic will be I, which is interest, which is the amount interest paid of earned. P, which is the principal amount of the loan or investment. R is the rate, annual rate of simple interest. T is the term, the time period in years of the loan or the investment. It is based on the formula calculate simple interest. Okay. What are the formula? The formula will be I equal to P times R times T. This is the simple interest formula. We're going to look at the simple interest diagram. Here I at the top of the diagram, PRT. What are the formula will we call I equal T, principal times rate times times. Okay? That's the formula. We can arrange the basic simple interest formula to give us the three new dimensions, which is the P. We're looking at the P. P equal to I divided by R equal to that times T. This is in terms of different dimensions. We can also rearrange the interest formula into new versions such as the R. R equal to I divided by P times T. So this is done. Okay. And then for the T, we're going to use it as simple T equal to I divided by P times R. Okay. Suppose you borrow $500 for 1 year at the rate of 6% per annum. How much simple interest will you pay? Given to you, P is 500, T equal to 1, R equal to 0.06, I equal to how much? Okay. The amount of interest you will pay is I equal to P times R times T, which is 500 times 0.06% times 1 equal to $30. Now the interest is converted to decimal form. Okay. If a 3-month term deposit pays simple interest rate of 1.5%, how much must be deposited in order to earn $100 in interest? So you're going to look at this simple calculation. T equal to 3 divided 2. Divide 12 you get 3 from here. R is 0.15 is from here. $100 is coming from here. What is the P side? So the P will be, based on the formula you're plugging in, all this formula is 100 divided by 0.05 in bracket 3 divided 12, you get 2667.67. Okay, this is based on an example of given to you in the formula. Just plug in the formula. Again, interest 78.42 was charged on the loan of 1500 for 7 months. What is simple annual rate of interest charged on the loan? So when you're going to do that, you're going to I here is equal to 78.42, P equal to 1500, T equals 712. What is R? You're going to plug in the R into the formula here given to you before. 78.42 divided by 1500 in close bracket 7 by 12 close bracket will be 8.96%. Okay, so you got the 78.240 coins coming from here, 1500 is coming from here, 712 is because of 7 months divided 12. So you're looking for the R for the rate. Okay, the annual interest rate, simple one. How long must you invest of 4,000 a simple rate? Interest rate of 2.5% in order to earn 50% interest. Okay, how are you going to do that? P equals to 4,000 equal to R 0.025, I equal to 75, T equal to what? So when you plug in the number, you get 0.75 years or 9 months. Okay, please remember, where you get 75 from is from here. I is at 75, right? Simple interest 2.5, okay? Why do you get the interest coming from? In order to earn 50 interest. Okay? P is 4,000. R is 0.25. $50. Okay, it's 9 months. Look at the next one. If the problem is given to you, you can easily convert to 3 years. When using a date, how much is the rate for the work for the exact number of days? You do this, you can use table 7.2 in the book. You can use a date function in the calculator. I remember I prefer to use calculator. In the old days, 30 years ago, 40 years ago, I always use the table because we do not have that calculator, the luxury. Now you have the luxury to have a calculator, use them. Once you have a day, you can convert the years dividing into 365. I'm going to give you an example of the date here per year. Month, January, and then still number of each day, okay? 1 to 31, 32, all the way to 100, 365. This is how you calculate the number, okay? Day of month, okay? January, February, March, February get up to 28, sometimes 29 every 4 year. March here, okay? Excuse me. Let's use the calculate 7th table, calculate number of days between March 3rd to August 21st. So at the beginning, you could just use the table to find out where there's a certain number of days, another date of the beginning of date, and you know the time or period at the end of the date. It's also worth pointing out how the years and how to leap years calculate times in terms of multiple years. This is an example, 62 there, 233, okay? March 3 is 62 days. August 21 is 333 days. The term will be 333 minus 62, which is 171 days. That's how you calculate. Okay? And then using a Texas Instrument B2, it has a built-in date function which has been used instead of 7.2. You can use access by second date. You can do second date here, DT1, start date, DT2, end date, and DBP, which is days between dates. Okay? How are you going to do that? We're going to look at this step by step. Second date here. Okay? The example given to you, interest investment $900 and $60, simple interest from March 23rd to July 5th, 2019. Okay, so what you're going to do that, you're going to put here second date 3.23.19, enter, and here enter, and then down under, okay, and then 0.7015, enter, down under. Okay, then compute. Type compute, and then second quit, and then you get the term is 104 days. That you get the number. Okay, you're gonna do this in your Texas Instrument. The step by step is given to you here. That's a good example. Another example. One interest will have an investment earn 16 simple interest from March 23rd to July 5th. Okay, so we're gonna do that. P is 900, I is 60, T is 140 days, because based on the calculation or the table given to you, what is R? R, when you plug in, you get 23.4%. Okay, and then you can solve this. Okay, question 1 and question 2. Calculate the amount of interest of an investment of 580 will earn over 3 years and 4 months at a 4.2 simple interest rate. I. Number 2, how long will it take for 650 to grow 72 at 5% interest rate? So the answer for 1 is $81.20. For the answer number 2, the answer will be 2 years, 2 months. Okay, this is an example for your skill check of simple interest. Then we're going to discuss about variable or floating interest rate. It is, what is this? It is the interest rate on loan and often linked to the prime rate charged by the bank. So I borrow a mortgage from National Bank, so I use a prime rate as a base. Okay, they use prime rate as a base. Prime rate is the bank lowest lending rates. Usually loan charge interest at prime plus anywhere between 0.5 to 5%. Okay, and then the prime rate is adjusted by bank to reflect changes in the financial market, so interest rate payable on loan may be vary over time. Okay, example here. I just borrowed 5,000 April 7 at prime 1% plus 1%. The prime rate was initially 3%. increased to 3.25% on May 23rd and to 3.5% on July the 13th. What was the amount required to pay the loan on August 2? So to solve this, we need to break the time period into separate intervals, okay, in each rate. We can use the formula by adding each of the formula by adding together at the end. So we're going to start from here, April 7 to May the 23rd, the first one. Okay, April 7 to May the 23rd, which is 46 days. The rate is 0.4%. Interest amount is 25.21. And then the second batch is May the 23rd through July 13th. Okay, it's 51 days, which is 4.25%. Remember, plus 1. Okay, the prime rate is plus 1. Okay, and then the amount is 29.69. Okay, remember the prime is 3%, so plus 1 will be 4%. Okay, July 13 is to August 2, second one. The third one is 20 days, the rate is 0.40%. Remember, it is increasing, okay? It is increasing. The prime rate from 3 to 3.5, 3.5 plus 1, remember plus 1 here. Where you got the 4.5 here, 3.5 plus 1. Where you got 4.5, which is here, 3.5 plus 1. Where you got 4, which is 3 plus 1 here. Okay, you're totaling it, you got 67.2. So the total paid need to be paid is 5,000 plus 67, you got 5067.23. Okay, this is the logic. Okay, this is given to you by the logic and you get that answer. For the I will be 25.205. Okay, all right, for the first I, for the second I, 29.692. The third I is 12.329. Okay, so that's how it calculates. Okay, look at the next subject, which is the maturity value, future value. When the loan or investment reaches at the end of its term, we say it's mature. The maturity value or future value is the total of the original principal plus interest due on maturity date. The maturity value is represented by symbol of S. Okay. Look at this one. The basic formula is S equal to P plus I. Okay. What is, we know that I equal to P RT, so that we can write the formula like this, S P plus P RT. So when you do that, we're going to combine S equal to P in bracket, close bracket, I plus R plus T. Okay. You borrow 2,000 for 8 months at simple interest rate of 5%. What is the maturity value of the loan? So given P is 2000, R is 0.5%, T is A divided 12, which is what is the S? So when you're plugging in, S will be 2066.67. How you get this 2000 coming from here? You're going to plug in the formula, 8 to 12, you get that number, okay? And then in terms of present value is the reverse, okay? So we can arrange an original value to solve the present value. This is the logic. So it becomes P present values as I LT. Okay. When we do that, look at the example here. Amount money would have been invested at simple interest of 3% per annum. And then in order to have 4,000 after 175 days. How are we going to calculate this logic? S is given to you 4,000. R is 3% coming from here. T is 175 divided by 3. What is the P? P, you're going to plug in that logic. So you got 3943.28. Okay? That's the logic for the answer for this example. We have a skill check here. Calculate the following. Number 1, find a principal of 225-day loan with a maturity value of 5680.44. Assume there was a simple interest of 8.3% chance on the loan. Then 4,000 was invested for 3 months at 5.7 simple interest, and find the maturity of the investment. So you're going to get this. The answer for this skill check will be, number 1 is 5403.95. Number 2 will be 44057. Okay, the third concept, which is time value of money. Remember this. Money received at the different point in time may have a different value. Example, you have $100 today, it's not the same as 100 in 1 year time. To find out 100 today will be worth in 1 year, we need to add interest and appropriate. We call it the time value of money. An equivalent payment has the same value of another payment once interest has been applied. For example, using a rate of 5%, the equivalent payment in 1 year today would be 105. Both amounts represent the same value just at a different point in time. We can use this maturity value and present value formula to calculate the equivalent payment. Okay, example here. Bob has promised to pay Sally $1,000 on October 1. Sally planned to invest in GIC earning 2.5%. Bob was late in his payment, couldn't pay Sally until November 10. What would be the fair amount for Bob to pay? The fair amount will be P is 1,000, R is 0.25% coming from here. In 40 days, so it's going to be 40 days. Remember, it is late. Okay? To November. October 1 to November the 10th. 30 plus 10, which is 40, 65. So when you plug in the number, you got 1002.74. So this is using this formula. Remember this 40 coming from October plus 10 days in November. So you got 40. Then second one, promise to pay, another example, to pay 1,000 October 1, but would like to pay her back week earlier on September 10. What would be a fair amount for Bob to pay Sally if he can invest his payment at the rate at 2.5%? Based on this logic equation, S is 1,000, R is 0.25, T is 21. Where you got this 21 coming from? October 1 to September 10. Okay. P, what is P? The P will be 9985.64 as of September. You can remember, you need to pay it back. For this October 1, going back to September 10. So you're going to go back for how many days there? Okay, 21 days. Okay. All right, let's look at remember, you from September 10 to October 21st, October 1 will be 21 days. That's where you get the 20 from. Okay, equivalent payment value of stream. A payment stream is simply a set of payment over time. To get the combined value of a payment stream, you can just add the payments up. You must take the time value of money into account. When solving this type of problem, a good timeline is helpful. Use a timeline. I usually use a timeline. A timeline shows all the amount in the payment stream on the dates they will occur. This is an excellent tool to provide us in delivering equivalent value to the payment system. Okay, remember, a clear draw timeline can really help. Okay, we're gonna look at this step by step. Here is again example. Consider payment stream consists of 3 payments: 1,000, 2,000, 3,000, March 1, May 1, December 1. Same year. Calculate single payment on August 1 that is equivalent to 3 scheduled payments. Use a simple rate of 8%. So we're gonna dial a timeline. March 1 here, 1,000, May 1, 2,000, August 1 is question mark. December is 3,000. When you calculate from March 1 to August 1 will be called S1, which is 150 days at 8%. Okay. Second one, which is May 1, 2000 to August 1, which is 90 days, 8%. And then the third one, which is December 1 to August 1, 122 days, 8%. So that is basically the total S1, S2 plus P1. When you calculate that number, you're going to plug in the S1, you're going to get 1033.534. For the S2, you're going to get 2040.329. Okay. For the P1, you're going to get 291 to 1.87. So the total will be, you're going to add this one up. Okay. The total will be exactly 5995.733. So that's how you calculate this number, this issue. You draw off the timeline to make sure you understand each timeline. March 1, May 1, August 1, December 1. All right, we're going to have another skill check here. The first skill check will be I and 2. Okay, the answer for the I will be 665.70. The answer for number 2 will be 1085.51. All right, let's look at another example here. Payment 5,000 due for 4 months, 3,000 due to 2 months from now. From now are to be replaced by payment of 4,000 today and second payment in 6 months. What must be secondary in order to make the replacement payment stream equivalent to the scheduled payment stream? Money in short term can earn 5%. So use 6 months from now on focal date. So you're gonna draw in the drive. 4 months ago, which is minus 4, and then 2 months ago, minus 2, and you got focal 0, and payment today, 2,000, second payment, and then that's 6 months. Okay, so once you do that, you're gonna plug in the number total from here to next one is 10 months. Okay, remember 4,000 today, second payment in 6 months. That must be second payment in order to make payment stream. So we're gonna look at this logic step by step. From 3,000 here, second payment is to S2. The S1 is 10 months. The S2 will be 4 months. This is the stream 1. And then another one, S3, 4,000, 6 months. Okay, S3 for 6 months. And then X for stream 2. Okay, and then you're going to calculate how you're going to get this number. For 10 months, it's 52083. How you get this number? It's from here. Okay, S1. From S2, how you get this number? 3050. This is S2. Okay. Remember, we're still, sorry, we were looking at stream 1 first. Okay, go back stream 1, 52083 and 3050. You got a stream 1. Okay. Then for total for stream 1 will be both combination of 10 months and 4 months. You got 8258.833. Okay, 8258.33 for the first stream. And then we're going to look at the second stream. 41,000. Where you got this coming from? This is the third one. 4,100. And then stream 1, 1 plus X. Okay. For the 2 stream, number 2, 8258 equal to X plus 4,100 equal to 825 minus 4, which is 4158.23. Okay. So that's a summarize. It's a little bit complex, guys. So you need to go over some of this question again. Make sure you understand it. This is a very complex kind of questions. Okay, you don't understand it, just going back again step by step. Okay, it's quite complex, this kind of scenarios. All right, the second example, calculating the size of the loan. A 5,000 loan advanced April 1 at 6.5% interest rate, require 1,800 on each of the June 1 and August 1. The final payment is October 1. What the final payment be to settle the full loan? X represent payment, set up time, its local date. Original date is April 1. Present value of 3 payment added together equals 5,000 loan. April 1, June 1, August 1, and October 1. Remember, it start with April 1, June 1, August 1, and October final payment. Then you get a 5,000. Remember, you got interest rate, loan in S1, 5,000, and April 1. This is the one. And then payment. June 1 is 1,800. August 1 is 1,800. What is the payment of the loan? October 1 is not question. It's no question mark. So you have to find these X things. All right. So you got this April 1 to June 1, 61 days. August 1 to April 1, 120 days. October 1 to April 1 is 182 days. That number, you're going to calculate, plug in that number. P1, you got 1780. P2, you got 1761. P3, you got the X. Okay, so the answer will be for this particular chapter to get this logic is 1505.12. Okay, this is a little bit complex. You're going to go back here to understand what's going on of the question marks. This is the logic given to you using a timeline to solve it. All right. So that is the answers for this particular problems. And then on this particular, we have a skill check for question number I and 2. The answer I will be 1596.30 and square answer for question 2 will be 1512.99. Okay guys, so basically conclude this particular chapter 7, and I will upload this in YouTube as well as a puzzle. Thank you everyone, hope you enjoy it. Bye bye.